So, hello everyone. A very good afternoon to all of you again. I am Pallav. Welcome you all again on behalf of eMobility Plus and the First View Group to the second day of EV Manufacturing Week 2022. The conference and the awards. I believe you had a good time with us yesterday, and nevertheless, we are here again for an action-packed day for the knowledge sharing, followed by the most awaited EV Manufacturing Excellence Awards in the evening. Hope you are exploring lots of stuff and networking with your peers in the networking lounge. If you have not visited yet, you are definitely missing the opportunity. However, no worries. That will continue till 5:30 p.m. today. But now it's time to start on with our second day conference. But before that, I take the pleasure to extend our gratitude to our presenting partner, Gendermark India Private Limited, again for extending its immense support to organize this event. And I now request our team to play our sponsor video to have a glimpse of their services and solutions. Okay, now let me quickly brief you about today's agenda. So, like yesterday, today also we'll be having two sessions. The first one on the next generation EV design trends, composites, architecture, and integration, and the second one will be on the cutting edge system modeling and simulation solutions to optimize cost, range, and performance. So, it's time to start today's program with the first panel discussion, which is on next generation EV design trends, composites, architecture, and integration. And to discuss this, we have in the panel with us Mr. Manikandan P, the founder of Greenberg Mobility Solution Private Limited, who is going to moderate the session as well. Mr. S.S. Sundaresan, sir, Vice President, Electric Vehicle and E-Mobility Solution, Ashok Leland. Mr. Sachin Agarwal, Senior Vice President, Product Development and Technology, VE Commercial Vehicle. Mr. Aniruddha Kulkarni, Vice President and Head Engineering, Tata Motors, Dr. Praveen Kumar, Professor, Department of EEE IIT Guwahati, Mr. Kumar Prasad Tilakapalli, the co-founder and CTO, Meta Motors and Energy, and Mr. Samir Jindal, Director of Engineering, MG Motors India Private Limited. I like to welcome all our esteemed panelists on the screen, but before handing over the session to Manikandan sir, I would I would like to make a small announcement for all of our attendees that if you have any questions during the discussion, please post them in the Q&A box. Our panelists will take those at the end of the discussion. I'm sure our panelists would love to address a maximum number of questions from the audience side, and we can make this session more interactive. So, friends, don't hesitate to come up with your questions. And now I request Manikandan sir to lead the discussion.
Yeah, thank you, Mr. Pallab Rana, and very good afternoon, one and all. Today, I welcome you to this session formally once again. Of course, we are gathered here to discuss one of the very happening topic in India as on today. So EV is now happening. I've been following EV industry for last 15 years, and I've been contributing to the industry as such. But it is a kind of happening thing now, and future mobility starts with the powertrain transformation, so to say, and this is just the beginning. What more to expect to happen in coming forward? Moving from by electrification, connected mobility, to autonomous driving, state-backed mobility, and finally the digital mobility which is going to come. And this is the kind of a transition phase now, and we are in the first step now. Of course, we start with the electric and end at digital mobility, and lots of things would happen in this.
So Manikandan, probably I'm thinking I'm not able to hear you. Are you on mute or others are able to hear?
No, we are not able to hear.
Mr. Manikandan, I would just request you to, switch off your camera and go on the audio mode only, because it's lagging from your end.
Still not able to hear you if you are speaking on mute. If you can unmute.
Meantime, I would request all the panelists, can you just, go up and introducing yourself? I would ask. I would request Anirudh sir to start your please. Can you?
So you want me to introduce myself?
Yes, sir.
Okay.
And
Thank
give
you.
us your perspectives on the topic first. Meantime, I will just connect with Manikandan sir to have the issue resolved.
Correct. Thank you, Mr. Pallab, and good afternoon, everybody. My name is Anirudh Kulkarni, and I head the commercial vehicle engineering of Tata Motors, which is our largest business. And I take care of the engineering of entire commercial vehicle range, which starts with a small commercial, pickups, van, light commercial, intermediate commercial, medium and heavy commercial vehicle range, then a buses, and also defense range. And I hold a degree in mechanical engineering and masters in systems. And I've also got leadership training in Michigan Ross School of Management and also MIT Sloan School of Management for the NPD. And I treat this as a great opportunity for all of us in this era. Like it's a lifetime opportunity, if I may say so. Like in 100 years, you become a part of like a transition, and here the entire world is seeing the transition from a say fossil fuel towards a net zero vehicle technologies, and we are our generations or the generations who are coming next to us would be, I think, the seeing this transition, which is very important. And this topic is so relevant, so important in today's days when we are working towards the net zero. So I'm treating myself honored to be part of this panelist, and also I will express my views as our moderator, Mr. Manikandan, ask us about some views and everything. So once again, thank you, and I'm honored to be part of this panelist.
Thank you, sir. Now I would just request Sundaresan sir to, with your small introduction and your views on the topic, please, sir.
Sure. Good afternoon, everyone. Great to be part of this panel and being present at this event. Uh, so yes, EVs are the happening topic today, and especially when it comes to commercial vehicles, it is in a very nascent stage globally. So there are lots of challenges, and each challenge is an opportunity to do something innovative. I look forward to hearing other panelists' views and answering questions from the other participants, and hope to learn a lot more about how these challenges are being addressed at various places. Look forward to the panel discussion. Thanks.
Thank you very much, sir. I would now request Sachin sir to come on the screen, please.
So good afternoon, everyone, and to me also it's great pleasure to be part of this panel discussion on most happening topic in automotive industry today, electromobility. So as Anirudh was also saying that it is driven by all CO2 reduction or greenhouse gas emission, and globally I think everybody is working on how to reduce pollution in environment. And electromobility, even though I agree with Sundareshan that for heavy commercial vehicles, it is a major challenge to have electric vehicle into series production. Uh, but overall ecosystem, if we see on the commercial vehicle or for complete automotive industry, this is the technology which is going to bring change on how we see automotives. So, a very interesting topic, and look forward to panel discussion. To talk about myself, I am responsible for product development and technology in Volvo Eicher commercial vehicles for complete range of trucks and buses. And we have products with two brands, Volvo and Eicher in India. And we also have complete powertrain development facilities, and that caters to global requirement of Volvo from India. So thank you very much.
Thank you, Sachin sir. Praveen sir, welcome on the screen and your perspectives on the topic, sir.
Yeah, thank you very much. So it's really a pleasure to be a part of this panel this afternoon. I'm Praveen Kumar, currently Professor of Electrical and Electronics at IIT Guwahati. And we also, I'm associated with the e-mobility lab here, and our work has been predominantly on the design of EV drivetrains for various applications. So I look forward to an exciting discussion today. Thank you.
Great, sir. So, going with the topic, as there are three prominent OEMs are with us now, I would just put an generalized questions put to all of you that, in your opinion, what are the key design challenges that the OEMs are facing for developing, the EVs? If we can just have the perspectives, Anirudh sir first.
Okay, thank you, Mr. Pallab, for selecting me as the opening batsman. So, so I personally feel if we see the challenges, and I would say challenges in the four perspective. One first challenge is to rightly select a vehicle platform for electrification. That is, I think, the first challenge which is there. Secondly, is like a proper integration of say EV powertrain on the vehicle system side, and also then we work on a various electronic architecture and other systems everything. Third, I think the important part is about the safety, and then durability part of that. And working for India, the working environments are different, the duty cycle environments are different, and there are many sub segments into which the systems are designed. So that is the third part, which is a challenge I think all OEMs have to overcome over that. And fifth thing is like a range anxiety, and then there the integration aspect of say our calibration or optimization or also on the validation front plays a very important role. So selection of say battery technologies, selection of say IVN networks and IVN protocols, or when we select about the battery chemistry, these are the challenges the any OEMs would face. This. And when we see the Indian commercial vehicle industries are having a diverse product portfolio. Some of the segments are like a small commercial where it is price sensitive. So the selection of technologies are has to be exactly as per the need of the market. And when we talk about say heavy commercial range, there the requirements are totally different, and there the reliability and the range, it becomes a very, very important factor. And the buses and everything are driven towards the STU requirement or a tender-based requirement which come up for the specific cities and everything. So, an OEM or a system supplier, a tier one supplier, have to go through all those four bucket which I mentioned: platform, integration, selection of aggregate, range anxiety, and safety aspect. Those are so important, and these are the challenges which we have to overcome. The technologies are maturing. Many of us have been investing on those technologies for many years. So I don't see much challenge there to lead this initiative, which I think toward the net zero part of that. And OEMs are geared up to overcome these challenges also. The last part, which is about the infrastructure availability, I think there has been a lot of active discussion with the government agencies and some of the say newer models which are getting applicated for the infrastructure development and the participation of say OEMs. There also, I think these challenges are getting overcome slowly. Thank you, Pallab.
Thank you,
Yeah,
sir. I think
Pallab, I'm
Manikandan
here
sir is
back.
back.
Yeah,
But just I like to have a small interruption because I like to have even we like to have as an audience the two different perspectives from two our other panelists from the OEM side for on this just briefly. Then you can lead the discussion, Manikandan sir.
sure, definitely. So I think very interesting point brought in by Mr. Anirudh. Of course, we will hear others also, and then we will take it forward. Yeah, I would like to start with Mr. Sachin. Probably we can hear from him as well. What is the challenges that he facing with respect to the vehicle designs?
Yeah, so I will bring my perspective more from CV product side, commercial vehicle
Yeah,
side.
yeah.
So commercial vehicle products, if we see, they are more for profit for
Hmm.
customers, and customer requirement is to run them more and more so that they can recover the cost at as earliest as possible. Now, what we see that major design challenges, what we see for EV adoption in CV products are basically range anxiety, or I would say in commercial vehicle, it is higher range requirement than initial price so that OPECO can be suitable, and definitely charging infrastructure or maybe technology so that time required to charge can be lower. And these are the basic challenges around which we are working for making this viable for commercial vehicle applications. There are many things that can be done, technology to provide better energy density in battery, because if you go for higher battery capacity, it means higher dead weight, and that reduces payload, which is not acceptable in commercial vehicle segment. And also it increases cost. So increasing battery capacity is not a solution. So what we have to work more and more is to work on battery technology so that we can improve the energy density and make it viable economically. Then there are definitely certain applications in CV, like short range application, intracity application for light duty trucks, or for buses. A lot of STUs are working on electromobility adoption. So these are some of the applications where definitely it is a very interesting technology to adopt, and there we are seeing a lot of adoption of electromobility happening.
Okay. Sure. Thank you so much, Mr. Sachin. So I would like to also to view some other view, from any other OEM side perspective, any other OEM side perspective, probably from Mr. Sundaresan on the Ashok Leyland front. What is happening in terms of vehicle building and what are the challenges that you are facing? Because
Sure.
I'll ask two questions to you. One is you are a designer, vehicle designer also. On the other hand side, you're also developing your own technologies, right? And you can look at both perspective and probably give us that this kind of answer, which can give us more overview on both perspective.
Sure. I think Anirudh Kulkarni and Sachin Agarwal have covered most of the challenges. I would like to focus on one of them that they highlighted, which is the aggregates selection. See, given that our volumes are low right now and the cost is a very important player, so
Okay.
actually the biggest technology is appropriate supplier selection. because no supplier is going to develop an aggregate specifically for our needs, given our low volumes. And typically, they try to sell us the aggregates that they developed for Western markets, which really do not, they are not the right choice for our market. So, and there is also, again, that's also the factor behind this confusion is that volumes globally are still on the lower side. And there's a lot of variation in aggregate to aggregate. It is not like a plug and play kind of thing, either in terms of the interfaces or in terms of the software. So we still see some time and distance to cover before there is sufficient maturity in this sector. So I think going forward for some time at least, this aggregate selection is going to be a key challenge, and uh, hoping for faster maturity in these aggregates, at least the interfaces, if nothing else.
Okay. So that means you mean to say that there should be some, kind of a technology development should happen in this area, and also some focused industry focus or the vehicle focused interfaces to be developed, right? And some design trends has to evolve, right? This is what my understanding is. That right? If that is the question, that is the case now, yeah. Now, what solution? I mean, how do we going to tackle this point? What kind of design aspects or trends that we are going to bring in? Probably you can start with that, and I also move to other panelists for this question. I mean, you can start how in your view, what is that it should happen?
See, it's not so much technology as such as some kind of, let's put it this way, some kind of norms or some kind of design hygiene, I would say. See,
Okay.
given that all, see, one this thing that we have seen is when compared to internal combustion engines with EVs, the number of subsystems has actually gone up.
Mm-hmm.
Okay. I mean, because you have so many power electronic devices, you have so many
Yes.
cooling circuits, and
Yes.
each cooling circuit comes with at least four components, if not more. So,
Mm-hmm.
with all this, some kind of integration, or if somebody is able to offer, let's say, an integrated self-contained unit with as minimal interfaces as possible, or at least all the HV interfaces on one side and all the cooling lines on another side. So integration kind of becomes easier.
Yeah.
See, now one problem with this bus STU business is, of course, now the CESL tender has to certain extent simplified it. But earlier, each state, each city would come up with their own tender specifications.
Mm-hmm.
So you have to spend your time redoing the mechanical packaging, etc., and waste a lot of time. And with this variation, also, if you decide to go to a alternate supplier, then again, because the interface is different, you have to spend a lot of time. So it's more a question of, I guess, maturity more than anything else, not necessarily technology. It is more in terms
Okay.
of the overall maturity of the industry
So
than.
yeah, Ms. Sundaresan, do bring in such maturity? I mean, you have brought in a very interesting point. Do we really look at the different our approach towards making the such architecture, such designs? For example, so we've been traditionally in automotive industry, it is more of a mechanical oriented, design approach has been made, and you also brought in more electronics, electrical is coming into the system, and systems are increasing, subsystems are increasing. I mean, no, probably this should be looked at differently. I mean, moving forward, I also know would like to bring in professor in electrical electronics, Dr. Praveen Kumar. I mean, he can bring in such triple E, I mean, electrical perspective to the whole system. And I mean, I would like to ask the question to Dr. Praveen that do we really need to look at our approach in designing this, the new architectures for EV or the aggregates for EV?
Yeah. So thank you very much. Actually, we
Yeah.
started working on heavy vehicles. It's actually thanks to Sundaresh, and he we partnered many years back and started working on that. But over the years, our take has been that going forward with the battery is a very, very bad idea for us as a nation and also for the heavy vehicles, because that's not a solution. And what we feel is that maybe we have to invest more on the infrastructure side, and we need to just do away with the batteries, and we should be actually just collecting electricity while on the move, and that is going to answer all our range anxiety questions. Maybe have a small battery pack, a very small one for limp through capability, but having large scale battery packs will increase our dependence on imports. Moreover, cell manufacturing doesn't happen in India. We have a wishful thinking of doing cell manufacturing, but we should remember the billions and billions of dollars that LG Chem or Sony has put in. They have not only put in the R&D, but they have produced Nobel laureates in those research labs. And thinking that we will catch up with them is virtually impossible. We have worked with cells for some time, and we discovered it's an art. It's more of an art than science, and it is transmitted from
Yeah,
generation
yeah.
to generation. So starting now won't help us at the cell level. So maybe yeah, something like inductive power transfer or even pantograph based systems would be a solution for long distance travel for heavy vehicles where we don't need heavy battery packs. And also cell batteries are very environmentally damaging. So if you see any cell chemistry, to produce 1 kilowatt hour of cell, we need to spend anywhere between 400 kilowatt hour to 800 kilowatt hour of energy, the primary energy. So most of the cells are energy negative, and the emissions are just way off the roof, anywhere from 400 to 600 kilograms for every kilowatt hour of cell produced or battery produced. So I don't think so we are going towards environment friendly or climate neutral technology with the batteries. And also we would be addressing most of the challenges if we rethink the way we are looking at the electric vehicles. So that is more or less the conclusion of our research here.
Okay. So, what is the suggestions from your side? When we understand that the battery and lithium ion and what is the consequence, and it has to be properly handled, and all that. But what is, according to you, since we are talking about heavy vehicle as a platform, even Anirudh started as a platform approach. So now heavy vehicle platform you consider, right? So commercial vehicles and high vehicles, should you suggest, for example, some solutions like fuel cells or hydrogen fuel cells can be more environment friendly alternate to the lithium ion, or what would be the kind of suggestion from your side moving forward?
Yeah, so first thing is that fuel cells won't be environment friendly because we still produce hydrogen from fossil fuel. We do not have a viable technology to produce fuel cell at a reasonable energy input from natural resources. Electrolysis is out of question. It's too energy intense. So that's really not a solution. But yes, for heavy vehicles, there have to be multiple approaches. So one is, for example, if we have city bus kind of application, so we did a lot of technical analysis, and we find that maybe supercapacitor based systems with flash charging at regular intervals might be a solution. For long distance vehicles, maybe the highways that we make should be made in a different way. So you have a smaller battery pack, and then you have lanes where the vehicles can charge while driving via inductive power transfer. So that can be another solution. Or maybe we can have the entire highways electrified, so while on the move, you are picking up charge from the road itself. And along the highways, of course, they can be fed by renewable energy because we have a lot of area exposed to the sun. So it has to be a very different kind of an approach. So I don't think so there is one size fit all from the research perspective that we have here.
Yeah, yes. Thanks, Mr. Praveen, for the. I mean, I just would like to summarize the discussion as for the heavy vehicles or long distance commuting vehicles. Probably we have to look at a multi-model approach rather than looking at a single solution. That is the kind of discussion that we are bringing in, right? So with that, I will move on to my next question to the panelists. It can be answered by anyone because I'm like bringing after this kind of discussion now to build the right EV architecture, right? We have many subsystems, your mechanical, electrical, electronics, and subsystem. So how do you kind of bring in what is the kind of a demand in today's consumer's mind when it comes to an electric vehicle architecture per se? More of electronics or more of software, and what is the consumer perspective, what is the OEM perspective? I would like to throw open, and anybody can start with this question actually.
So just
Okay,
like to
yeah.
interrupt in between, I just like to inform Mr. Prasad has joined the panel.
Oh, thanks.
Great.
A warm welcome,
Yeah.
Mr. Prasad.
Good afternoon, everyone. I'm really sorry, got stuck in a board meeting, so I just had to take.
No issue, no issue, no issue. A quick 2 minutes introduction about you.
Sorry to break the flow, but it's all yours now again.
Yeah. Sure. Then probably, this is what I wanted to know. What would be the best architecture in terms of a new EV electric vehicle, considering the platform that will have a more electric and more subsystems like electric, electronics, software, and hardware. So I would like to start with Mr. Sachin Agarwal himself. According to you, what would be the way forward in terms of building the component architecture for EV?
See what you said, Mr. Manikandan.
Yeah.
From commercial vehicle perspective, I think user requirement will be the key. And
Yeah.
most of the commercial vehicle, if you see, their applications are some duty cycle based. So first thing to consider is their duty cycle based torque and power requirements, considering all operating modes. Then and how much energy supply they need, and how do we manage that energy, including charging, regeneration capability, those type of potential which is there in our architecture, EV architecture. And then one thing which is very important to focus in EV architecture will be on drive cycle efficiency. So
Okay.
the cycle where he is running all these softwares and our electronics, that has to answer that efficiency is maximized. Then definitely we have to consider there are many subsystems which are there in vehicle. Some vehicle is with air conditioning, some is not, some is with air brakes, some is not. So that electric power demand of various subsystems, and there I would say the vehicle control system is going to play the most important role in EVs, through which you can optimize basic utilization of various auxiliaries which we are using on the vehicle, and this will also help into optimizing the overall weight and volume of various components. Now, couple of more
Okay.
things which I think initially Mr. Sundareshan also touched upon, uh, that most of us are working on converting ICE based vehicles to EVs.
Yeah.
And when we are doing this conversion, we have to look at aspects like modularity, which is very important. That when we have different type of powertrain, whether we have EV or ICE based powertrain, how to build that modularity. And when we are focusing on EV architecture, one very critical thing is how to place HV and LV, high voltage and low voltage systems, so that we have easy serviceability, easy maintainability, and also easy packaging. And this will also bring into now safety related aspects, because today we are having very low volumes on EVs. As volumes will increase as we go into mass production, knowing that we are now playing with high voltage system onto the vehicle. Today, even with 24-volt system, we get certain thermal incidences on the vehicles in field. So we have to be very, very cautious that with 650 type of volt system on vehicle, safety parameters become very, very important. So these are some of the aspects which we feel are very important when we decide system architecture for EVs.
Was
So,
very, very interesting. So overall efficiency, safety, and the system, energy utilization at various subsystem level, and these are the key factors for building, any EVs, moving from the commercial ICE to EVs. Interesting conversation.
Mani, can I
So
add on this?
yeah, can you add? Yeah, please. Yeah.
Yeah, see, I think now what Sachin mentioned is absolutely right. But if you look at the overall perspective of architecture,
Hmm.
really in terms of the electronics content, the amount of control related software, and the way the entire architecture is framing up, right?
Yeah.
Safety,
Yeah.
reliability, and security, all three. Functional
Yeah.
safety, constructional safety, electronics reliability, and security in terms of cyber security. Because I mean, there's so much hype around data, but you have to understand, there is a lot of thought which has to go into the E&D architecture when you start talking about monetization is good, but at least you need to make sure that the threat perception on the vehicle for the consumer is really not big, right? I mean, that means a very robust E&D
Yeah.
architecture. And
Yeah.
this,
Yeah.
especially when we talk about non-powertrain components too. Especially if you look at two-wheeler industry, there's been a huge shift towards modems. Everyone is very happy to see infotainment modules coming onto the two-wheeler ecosystem too, away from a standard instrument cluster that was steering you. But you also have to remember that these modems are non-automotive grade, and you're baking them in sunlight, in a two-wheeler, which is exposed to, let's say, about 150K lux in India. That means you have a continuous heat source heating your instrument cluster. I am guaranteeing you that the maximum returns the industry is going to see here is irritant with respect to the biggest graphical user interface for the consumer, which is your infotainment system too, right? I mean, the feedback that's coming in there. Then, the whole architecture itself, when you look at it from a safety standpoint, it starts from hygiene. Do you have development interface agreement with your suppliers? Is a HARA done properly? Do we know the safety goals of the vehicle and how it is flowing down to each component's level, right? And then it talks about technical safety concept, implementation, and the next steps of it. So this, I think, is a very responsible element. And like what Sachin said, right? I mean, retrofits of IC perspective, and as a standalone, architectures versus a complete E&D architecture and a vehicle architecture too, for that matter, right? I mean, all of this has to play in together, and it starts with a very strong responsibility at the OEMs. We need to be, and then, a distributed responsibility with the partners, be it the suppliers, then the testing ecosystem like ARI, or an internal perspective too. I think this is going to be a crucial differentiator to see whether faster adaptation happens. Are we still continuing to play with concepts? There's a big difference between making a concept and a product. I think that is something that everyone in the industry has to realize.
Very interesting point, Prasad, that you brought in between was on telematics and connected services. Because now with electric vehicle, because everything is governed through your softwares or architecture, so it's very important for customer also to get all the data, and it is very easy for us to provide that service or to that facility, which is added advantage to customer. So very good point, Prasad. Thank you.
So, Mr. Manikandan, I have
sure. Thanks. I think Prasad, you brought in, you added spice to the whole conversation now, right? We have been talking about architecture, systems, and building EV and commercial vehicles, and you brought in the data, electronics, software, and cybersecurity aspects. Of course, this is the way forward. I mean, that is what I wanted to take the conversation to the next level. Now, should we be doing it, simultaneous engineering, or should we be doing it everything parallelly, or should we be doing a staged approach, in a kind of commercial vehicle development? So, what is the best approach, or should we need to take the support of some tools like product lifecycle management? Because new age, everybody talks about some product lifecycle management. So should we take the support of such tools, to have this the complete approach, systematic process-oriented approach to build such systems? And data is new oil, right? We all know that, right? So instead, we have to also build systems. We collect data. On the other hand, we also need to see how do we optimize and the energy utilization and the performance of the vehicle levels and things like that, right? So vehicle control unit do this work. But what is the kind of approach? Should we have a PLM implemented from day one in the system?
So, Mani, I think a very good question. First of all, I think this is, I think, there's no substitute to a systems engineering approach. PLM and the other tools that we speak about, right? I mean, they're all, I mean, as you say, right? As everyone says, a tool is as good as the guy who is implementing it. Right. I mean, and I think it is about more in terms of the approach that you follow. And I think the most critical thing, which I have learned from my own experience in the last 2 decades, with auto electronics and EV platforms, is there's no substitute to systems engineering. You have to visualize this in terms of a system architecture. And then you are essentially talking about how do you leverage digital platforms and the digital power that is available right now to create MVPs which are not based on metal and get your architecture part of it and planning through, which is maybe leading into the next session, but there's no substitute to actually doing a lot of virtual analysis. And thankfully the industry is sitting on top of a lot of heuristics in terms of data, because because of the hybrids that have run, the powertrain related scenarios are not really new. I think we need to be very clear that we are offering a mobility solution finally, which the end consumer knows how to use. So the usage patterns are pretty much defined. There are multiple other use cases which come in, which we'll have to factor in. But when you take all of this into cognizance and look at the information that is there earlier, right, and bring it into the architectural study, do a lot of virtual, evaluation with respect to what does it mean from a component sizing, what does it mean from a control area network based, in-vehicle networking related scenarios. What does it mean with respect to when you add topics like telematics, what's the penetration levels that you're getting your whole system to? So this piece of it has to be front-ended in any case, there's no substitute to it. The only thing is with digital tools that are available, you can accelerate it quite a lot right now. I mean, I think what was 42 months in terms of development cycles are shrinking to 28, 36 months or even lesser. Okay, so there's, to answer to your question, I think sequential part is really not the way. Systems engineering approach is the way. And this means basically you're feeding in requirements to mechanical, electrical, software, safety and validation teams together. And then, earlier, if you look at it in the ecosystem, there's always used to be a tiff between a simulation guy and a validation guy. In terms of, who is actually adding more value to it. Yeah. Now it is more in terms of how you are able to leverage simulations to make validation more meaningful, right? I mean, data-driven approach where you know that you are not just academically testing things to prove that you are right, but actually focusing on 20% things where you will fail, right? I mean, which you know from your virtual analysis, and then dig deeper in terms of validation. So I think these pieces are essentially also becoming quite parallel in terms of processing, because the engagement of different teams is happening quite early. And same thing with respect to the manufacturing ecosystem too, right? The way you handle, let's say, lithium-ion battery is as critical in the manufacturing facility as it is in a vehicle environment. So if you don't get it right, your yield factors will kill your pricing, and then you essentially come back and say that we need much more funds, or more incentives from the government. So I think this is the piece which we need to get together. So for me, I think the most important thing which has helped me, and I've seen this both in established organizations like Mahindra and Eaton, where I was responsible earlier, and in our startup right now, there's no substitute to a good systems engineering approach here, Mani.
Perfect. I think you have really elaborated very clearly, and we understood. One thing I just wanted, because when you talk about this creating a digital twin, and working virtual validation of the early stage of the life cycle, and doing simultaneous engineering, both design, manufacturing or industrialization working together. I mean, that is the reason why some of the two-wheeler OEMs, they also promised that they will release the vehicle in 8 months. They did this also. I mean, some of the examples that we can see, it really the fastens or speed up the whole development process as such, right? And that is some examples already is there in the market, and we can see that. But when we are talking about all these, creating a proper architecture, creating a component sizing, processes, system-oriented engineering approach, what we are thinking is probably we are looking at how do we optimize the whole the vehicle energy utilization in the vehicle. How do we bring down the optimization at all various levels, subsystem levels and system level, and at the vehicle level, so that we will be able to achieve our targets in a much better way. The targets in the sense of range, acceleration, and top speed and torque requirement, which we can achieve in a very much better way. So we have to see how do we do the optimization, right, at various levels. And when I think about optimization, should we not think about kind of a lightweighting also as an approach? Because we are all working and developing some heavy vehicles, right? So what is your start with Anirudh again. So do you do anything on the lightweighting side of the story, and what is your takeaway on that? How do you optimize using lightweighting of the some of the system component?
Sure. So, Mr. Manikandan, I just wanted to reflect on first two questions also a little bit because I could not reflect and I could not resist myself in responding to those.
Sure, no
One is,
problem,
I
no
think,
problem. Quickly, yeah.
one is the
Nothing
Indian
problem.
automotive industry is having many product segment and many product duty cycles. So the solution which we say that some solution may work for some product categories like a heavy commercial, some solution may work for a light commercial, some solution will be required only for the small commercial areas and pickups and vans and whatever that. So when we speak that fuel cell may not work or battery electric vehicle may not work in India, this is probably not correct. And there are the different solutions and the technologies are really progressing very well. And I will try to reflect onto your the previous question and the question which you asked,
Yeah.
and I will divide like a vehicle is divided into three parts. I'm just for a simplification, I'm just mentioning that one is what we call the rolling chassis. You have a frame, suspension, steering, then and say brakes and everything, where the technologies are also progressing to adapt to a from a fossil fuel to a electrification fuels.
Mm.
Okay, whether it's a battery electric vehicle or a fuel cell electric vehicle, the technologies are progressing, and it is progressing rapidly, very fast with a weight optimization also. The second part of the vehicle, which I'm very generalizedly mentioning, is about the HV architecture or a powertrain, like a heavy HV architecture and LV architecture. So like motor, onboard charger, converters, batteries, and then your BCS and torque controller, all those areas where we are saying that the system engineering approach or you are saying that optimization approach is
Yes,
happening.
yes.
Here, it is again. I'm just mentioning that it is not the one common solution for all segment
One
in
second.
India or for all segments in India. So the requirements, which are whether it's a algorithm development. Earlier, we used to call vehicle dynamics means only suspension tuning, ride and handling. But now the new terminology of vehicle dynamics is the algorithm development, the calibration development, the safety protocol, the cyber safety protocol, functional safety. All those comes into picture, and the right sizing of the component for a particular duty cycle are required. And I can also mention, since everybody is discussing about a heavy commercial, I will also express my view. Heavy commercial vehicle also there are like a 10 different segment within India, 10-20 different. So one solution may work for a cluster application, another solution will work for a set tippers, something will work for tractors. The third important part of the vehicle architecture is on the bodies, like whether it's a truck bodies or you have the buses bodies and everything, where which is interacting with the user. And this was also related to your experience, your question number two, like what is the customer is expecting. Customer will not understand what you are giving under the hood. His expectation is that I should get a quieter vehicle now because he was used to for a fossil vehicle. Now he's going for a say electric vehicle. So his requirement as for the comfort, convenience, human machine interface, or the data point which he is accessing through his telematics unit, are his expectation is totally different. So the work which is happening is not only on the say weight reduction of say the load bodies which you are offering, the container bodies which you are offering, or a bus body which is going on like aluminum or a panels or a truck frames which are going from a XYZ technology to YZ technology like this. These are completely different. So customer is interacting with that, and
Yeah.
that is so important. And as we were just discussing, the customer is expecting now is like a range. So that means he is asking us to that, yes, you work on a say lightweighting, so I get a better range. You optimally select the algorithms so that I am able to optimize the motor size or my pack size. And then he is not worried that whether you are selecting a LFP batteries or you are selecting NMC batteries or you are selecting a fuel cell stack from a XYZ supplier. He is expecting that my vehicle have a particular range. I should have a safe, and if I'm getting a fast charging, so the range anxiety is gone away and everything. So the industries like OEMs are having a challenge like this. Like when a large portfolio is handled, the modularity aspect which I mentioned is plays a very important. Like how you share the technologies across the platform within the platform, and then how you work on a say lightweighting. When you say the frame lightweighting with a say higher strength material which is coming up, when you talk about say load bodies, like again a high strength materials are going, people are going away from say traditional steel to say aluminum honeycomb structures, or they are going with a composite material for the container bodies, or they are also going with the say DCPD technologies going on certain applications, everything. And when you talk about say aggregates, like again a heavy HV high voltage aggregate, that the right sizing plays a very important role. Whether you have a say
Understood.
transitional gearbox in between, or you have a proper algorithms developed so that a proper efficiency of the vehicle enhancement happens, or you work on say drag reduction. So these are the
Yeah.
technologies focus which are happening. So lightweighting is one of the aspects, but in India, one solution is not, there is no vanilla pack solution for in India for a large portfolio which we have. And this is what my
Achha.
views and everything. So I thought that I should just mention. And there is a future also for electric. There's a future for the fuel cell, and then the solutions are different.
So that means what I'm trying to understand from you is the multiple solutions will coexist, and also different, what you call optimization techniques. Not only lightweighting, there could be other form of optimization also possible at the system level. Is what is a converse. My understanding is correct, or
Absolutely. So we are fighting, like
yeah,
OEMs are working not restricting their approach only on a say lightweighting. Lightweighting is a must, but the industry would be moving from a say fossil fuel getting converted from a diesel to electric vehicle
yeah,
to a born EV or a native EV kind of a product. And there we cannot restrict ourselves only on a lightweighting, but the algorithm developments, right
yeah,
sizing of aggregate, the selection of various material which is going below the floor, above the floor, and also for customer
yeah,
centric aggregates, which
yeah.
are we are interacting and everything. So you will find a different ball games altogether and everything
Yeah.
going
Thanks,
forward.
thanks, Mr. Anirudh. I mean, I have got the clear understanding on this approach, but at the same time, I would like to also validate my understanding once again with the inputs from Mr. Sundaresan. You are our own friend, in Asok Leyland. What would be his approach? I would like to know. Mr. Sundaresan, I would like to know how do we kind of should we now taking clues from Mr. Anirudh's conversation. Should we fix up some kind of a criteria or some selection approaches at a different vehicle segment? What could be the approach, say, selection approach or criteria that we can fix in? If you have some ideas on that with the design thinking.
Yeah, so it is a challenge, as Anirudh mentioned, given the fragmentation in terms of variants, applications, and all the things. And again, as I kept mentioning, volumes, we are still dealing with very low volumes to do any kind of specialization to make the vehicle really cater to a specific application. So you need to kind of see where you want to compromise, what are the, it's a trade-off analysis end of the day.
Okay.
Multi-object objective optimization, not a single objective. And similarly, in terms of levers also, you have multiple levers. So lightweighting is one lever, then the right sizing of the component is one lever, then what are the various algorithms you can do. See, end of the day, you need to make sure where are you losing, what are you losing. So maybe by moving a component somewhere, you are avoiding making the, let's say, the cooling circuit more efficient. You are kind of reducing heat pickup. So things like this, you need to look at each and everything and extract the best out of each component, and need to have that system view, need to have start at bird's eye view and go all the way till the detailed design. Look at where
Yeah.
all there is opportunity for optimization, you need to do that. No
Yeah,
single
that means it
solution.
has to be looked at a multi-segments level. We definitely cannot fix any particular kind of a framework or something. That is what is saying. But it is only a system approach that is has to be used. Understand? Good. I think moving. I think it is kind of both of you have really given us a lot of insights on how do we do the optimization and also at the power system level. So moving on to this to the powertrain again, I'll go back to Mr. Praveen and Kumar, both of you, in terms of designing the powertrain, because I also come from the powertrain area. So how do what are the opportunities in terms of first of all the effective power utilization? How do the power system should be designed, and what kind of a right architecture for different vehicle segments, maybe focused on the commercial vehicle, light commercial vehicles, and what could be the typical power system architecture that we can think of? And you have any suggestions, ideas in your experience, which can be further, beneficial to the whole team here, whole audience here?
Yeah, when we talk about the architecture of the drivetrain, so we like to do, at least in our entire research group, is that we pay a lot of attention to the thermodynamics. So we say that, okay, we can have great softwares, we can have over-the-air updates, everything is fine. But at the end of the day, it's the thermodynamics which will determine whether we are going to have a great design or not. And for that, we should know every watt hour of energy that flows from point A to the last point, okay, from the point of origin to the point of consumption. And the rule of thumb is that have as small a path for the energy to flow and as safe a path. So keeping that as a constraint, we start to design the drivetrain and also the components. And if I look at from the motors point of view, which is our primary area, so yes, there are new kinds of materials which are coming up for the lamination of the motors, which can reduce the losses there, increase the overall efficiency. New styles of windings which are coming up, new cooling. So a lot of attention has to be paid to the cooling, because at the end of the day, any system is as compact or as small as the cooling system is. So if we can extract the heat right at the point of generation, then we have a very efficient system. Okay, but that cannot be feasible all the time. So what are the new ways of cooling the system? But again, then we need to take care that cooling also has its own limitations. Today, we read a lot of advertising material that people have come up with motors of 10 kilowatt per kilogram power density, so on and so forth. Fine, yes, you can do that, but how big is the cooling system? So if I take the motor plus the cooling system, I don't think so we went anywhere, because your efficiency, let's say, is 96% for that small motor or a big motor. You're producing the same amount of heat and you're producing the heat faster. So it needs to be cooled. So I think, yeah, these are some of the issues that we need to take care of, and we should not be swayed by the claims until and unless we look at the entire system and not just one specific subsystem. So
Understood.
yeah, these are some of the points which we need to pay attention to.
Okay, good, good. I think, yeah, definitely that is the one thing which is everybody's interest also. I mean, safety and temperature management, thermal management is a big talk, big by itself. In designing overall system architecture for powertrain. Mr. Kumar, are you there? Kumar Prasad, I would like to have
Yeah,
your input on
yeah, Mani.
this particular. Yeah.
Yes. So I think, it's first of all, Praveen, I think mentioned something which is very crucial. I spoke in the context of thermal in even telematics earlier for infotainment screen too, you know. But essentially, when you look at the power density and energy density, when we speak about for powertrain components, essentially, I think we need to also acknowledge that the power electronics and VLSI has really stepped up, and it's they your solutions that you are looking at are extremely efficient, and at the same point of time are able to scale up to give you a modular architecture where you can optimize these packages to different solutions that you need. So I think while we it's very important and be pragmatic to see that, okay, you are in looking at thermal management and everything else that is coming together, to look at power density in a holistic sense, like what Praveen said. I think we also have to understand that the right technology to adapt for every application might be a different one. So it's very important for people to actually step back and look at, what does it mean for a two-wheeler, what does it mean for a three-wheeler, what does it mean for a four-wheeler application, and then and come back and summarize the solutions that you are looking at. The bottom line for this is not going to be looking at whether we are able to deliver the power level at the wheel, but it's also about how efficiently are we able to deliver. I think that's the bottom line of what we need to look at, and this is a distributed architecture. So I think we also have to understand that industry is very responsible, and if someone makes a claim that 95 to 96%, there's a data which is worth its millions, which can back it up. So we can't just say
the
that
temperature effect and environmental effect
these
also to be
numbers are less,
considered.
because you have to really understand that there's a lot of money, there's a lot of effort, there's a lot of talent which is right now working at e-mobility industry, especially in India, which is pushing the boundaries. So I think we need to be cognizant and saying that when these numbers are placed, there's a lot of effort which is basically talking about these numbers, and there's not some gimmick coming on to the media or others. That's the bottom line I want to correct with. And as technology is helping us get there, it is required that the academia is also able to do act and things that matter. Is very important
Thanks.
to look at an academic way. Yeah,
Mr. Kumar, I think very interesting. I think we had a good conversation. I think we are also slightly crossed over time. Before moving, I have a lot of questions from audience also. So moving to audience, I have one last question. What is the suggestion from you to convert an IC to an EV? Will that work? It will not work. I mean, a quick opinion, probably from each one of you. There's a good approach to convert retrofitment. I'm talking about retrofitment of ICE to EV. Is that a good approach or it's not a good approach? Mr. Anirudh?
So you are asking an OEM about this question, but definitely I will try to answer slightly in a different way. There is not a single answer to this question whether it is yes or no. When we see it from, say, vehicle which are flying on the road, there has to be different solution. But then the solution which we provide, as you rightly said, is like a retro, is not going to be like not a efficient solution in that way. And then there are many players right now who are doing the retrofitment, but they are bound by the present architecture of the vehicles. Correct. So whether we are saying that the current electronic architecture has gone away from say distributed architecture from say generation 1, 2, or 3 to like a domain control architecture, or then it is like going to a vehicle central architecture. Those flexibilities would not be available as a retrofitment kind of a thing. The space, the weight, and then the selection of aggregate which is suiting to a very general mass available in the say market, those will be posing a lot of challenges. Whereas the non-retrofitment, like we are saying that a present vehicle, but very at least like a 30%, 40%, 50% optimized solution which can be offered by the OEMs in the market. That is also one solution which is also a good option. But whether that is sufficient may not be right now. But for the next 5 years, 6 years, 7 years, the solution may work. But going forward, the India will definitely need like a born EV or a native EV kind of a product. And there, the solution, I think, is important. And that's why the industry is, as rightly said, OEMs, the tier 1 suppliers, the industry academia relations, this plays a very important role in those aspects. The last aspect is like a vehicle safety. When you do any retro activities in the field, the safety aspects very, very played. And when you work on a, say, HV architecture, those poses a lot of challenges. So we cannot sometimes play with the vehicles. We cannot play with the, say, life of the vehicle, the people who are using it. So that's why there are many challenges. There is no answer which is right now industry has found out. We have the answer through the regulations, and then industries are working towards that, including all of us.
Thank you so much. I think we had a very interesting conversation. There is one audience question before I come to the closing summary. There's one question from Mr. Dawal Salha. So he's asking in the traditional industry, there are a lot of mechanical engineers or IC engineers in the system. So moving forward, it's going to be more electric, and we need to bring in more electronic and electric skills. And what is that? How the country is approaching this challenge is one question. Anybody would like to answer? Either Mr. Praveen, from the institute perspective, do you do any program?
Yeah, and to address the challenge is to really ramp up the education infrastructure, addressing the needs of these technologies, which most of the IITs are now doing it at least, but I think it's not really sufficient. It has to be scaled up on a larger scale. So apart from that, I don't see any immediate solution to the problem.
Okay.
It needs heavy investment.
So
I think,
anybody from the OEM side, are you doing any reskilling or upskilling programs to do this? Take
So
up this challenge.
Mani, I can share what approach we follow. We feel that whether it is ICE-based or EV-based, 70% work content remains same. What
Okay.
changes is only 30%. Like in between, Anirudh also explained, if you consider automobile into three parts, what is changing is powertrain.
Yeah.
There are many other aspects on the vehicle, whether it is rolling chassis, brake, suspension, steering, that remains same, bodies remain same. So only 30% portion is changing, and there we are doing lot of work on reskilling of people, because one is that we get new people, new skills, that is also important, but what is also important is that people who are skilled over period of time on powertrain, they are reskilled to handle electric solution also. So this is the approach we are taking, reskilling our existing manpower, retaining existing manpower who are expert into other domains, and also getting new talent, new expertise which are exclusively required for areas like system engineering or architecture, which are our battery. So these are very specialized area for which we need new domain experts.
Interesting. Perfect. I think overall it's a very mind-boggling and enlightening discussion, I would say. I got a lot of insights into, for example, platform development. How do we do the platform approach, integration, and in terms of aggregate selection, and the various methods by do the system engineering and overall efficiency improvement, optimization, and different models to go existing, working together. So a lot of things that we have learned in today's conversation, and with this feeling, I would like to leave it to Pallab to summarize the whole session. It was really interesting discussion altogether, and a lot of insights. Thank you so much thanks for the panelists individually and your contribution and the way you handle the topics. Thank you so much. Leave it to you, Pallab.
Thank you very much. Our first of all, our esteemed panel for this wonderful discussion. Um, you're devoting your time for this session and making your support towards the discussion. A special thank to Manikandan sir for the superbly conducting the session. Your industry insight and technical expertise brought the best out of our panelists to make this discussion even more informative, thought-provoking, and interesting. Though we are bit overscheduled now, but the things are necessary to sum up all this, binding in a complete picture with the topic. So thank you once again, and we will now move to our second session. Audience and our friends, can we have a virtual round of applause for this panel? Great. So thank you all panelists once again. We will now move to our second session. And audience, we'll be having a short break of 10 minutes, and we will be coming back in just next 10 minutes. Do join us back.
Thank you very
Thank
much.
you. Thank you, everybody. Thank you, Pallab, for the session.
Thanks,
Thank you,
everyone.
Mr. Manikandan. Okay. Bye.
Yeah. Thank you so much. Thank you so much.
Thank
Bye.
you, guys.